Zero work conditions. Now see conditions of zero work. Okay. Now basically there are three conditions of zero work. First of all, the applied force is there, but displacement is not produced. Okay, for example, you try to push the wall. You are applying force, but there is no displacement. Okay, so this is the example of zero work where there is application of force, but the resultant displacement is zero or there is no displacement.
Why is the unit of displacement? Why do you write S for displacement?
That's the symbol. That's the international symbol. Okay. So applied force is there, but displacement is not there. This is the first case where zero work is there. The second case of zero work is when force and displacement, both of them are perpendicular to each other. Okay. Yes, the perpendicular means 90 degrees. Okay, I'll just consider example of the earth revolving around the sun. Okay, now suppose here this is the sun and this is your earth. Okay, it is revolving around like this, suppose. Now there is a gravitational force between the center of the earth and the center of the sun. Okay, the gravitational force is there between the sun and the earth. So this is the line in which the force is acting. Alright. Now the earth is moving rotational. It's having rotational motion. So at any instant, the direction of motion is like this, tangent. Now this angle between them is 90 degrees. Okay. So in this case, there is gravitational force, there is displacement, but both of them are at right angles to each other. I'll consider one more similar example of these. For example, you take a stone and you tie a string over it, and then you just hold with your hand at some distance where the stone is tied to the string you are holding, and then you just revolve it. Okay, suppose here this is the position of your hands where the string is there and the stone is moving like this. Okay, at any instant if you leave the stone will go and fall like this. Correct? Suppose if the stone is going round this way. At this instant, if you leave the stone, okay, if you leave the string, the stone will go this way. So what is the direction in which the motion is taking place at any instant? It is along the tangent, that is perpendicular. This is the force of the string which is holding the stone. Now both of these directions are perpendicular to each other. So therefore in this example also no work is done. Displacement is there. Okay, this example is not there in your book. The displacement is there, but there is no applied force. For example, an asteroid that is traveling in some space, it is not getting attracted by anybody, it is not getting pushed by anybody, it is just moving constantly. The speed is constant, it just keeps on moving. There is no force acting on it, displacement is there. Okay, so this is the third example where force is not there but displacement is there. Okay, no applied force but displacement is there. This is also an example of zero work. Now the examples that are mentioned in your book. Okay, a person walking in a straight line, straight direction. Okay, in this case also the work done by gravitational force is zero. That is not mentioned in this, which there is a mistake over here. Okay, work done by gravitational force is zero. Then a coolie carrying a load on his head and walking on the road. Now obviously, suppose if I am taking, this is the coolie. Okay, now the load is over here. Now he is walking like this, in this direction. What is the direction in which the coolie is applying the force? This is the direction. What is the direction in which displacement is taking place? This is the direction. So the work done by applied force is positive in this case, but gravity Where is gravity acting? Downwards. Where is displacement? Horizontal. What is the angle between these two? 90 degrees. So work done by gravitational force in this case will be 0. Is that clear?